Hello, my name is Charlie Barnes, and today we will be talking about our ignition system for our 2018 Hyundai Tucson 2.0 liter front-wheel drive vehicle. And today we'll be talking about its coil and plug ignition and how it operates. Coil and plug operation is typically, it has a coil that sits above the spark plug and basically transmits electricity onto the spark plug to induce for our ignition as well as our timing and spark advances as well. Over the visual inspection, we see no signs of carbon fouling or carbon tracking. Coil and plug wires need to be inspected and repaired due to us being able to see exposed wire that leads up to the actual coils themselves, and we would advise for someone to either repair or to inspect that system. Pin 1 of the coil and plug is ground, pin 2 is our power, and signal is not necessarily designated for our pins due to us only having 2. Our injector, our ignition coils are in parallel. They have shared windings, which means they have married windings, which they are in parallel, and resistance may appear to be inconsistent using a meter due to them being shared in parallel. I know that pin 2, being our power, is also the same for each and every ignition coil. So to measure that, we would have to use a meter, and we would have to try and get a reading, but when we try to get a reading, we get a very inconsistent reading. Primary one, we were able to find an injector value of about 1.9 ohms, but to specification is about 0.75 ohms, plus or minus 15% at 68 degrees Fahrenheit. And for winding number 2, it's about 5.9, plus or minus 15% at 68 degrees Fahrenheit as well. These ignition coils typically vary within temperature as well as operation of the vehicle. Due to us having an integrated igniter as well as a driver, we are not able to necessarily read and get a good specification reading, especially from our multimeter itself, due to how our system is operated and how it works. Our instructor had also prompted us to possibly move to a different vehicle, especially when we get to about step 5 for a waveform reading. Due to our coil and plug being parallel and it being a married system, it is very difficult for us to be able to get any type of reading whatsoever, and for our paddle to interact with the coils and its activity itself. Mr. Kurt actually advised us to move over to the Cadillac that's in the lab in about the same bay, where we will show you all our testing as well as our waveform analysis.
We're observing a waveform of our paddle today over each coil and plug.
Hi, my name is Ajani, and I'm going to be picking off from where Charlie left off. So, starting with the 5th step, ignition timing, going through all data, we were trying to find if there were any procedures that the ignition would take on its own, and we found that the ECM controls ignition timing. There's no way you can adjust it, so we pretty much just moved on to the next step from there. There wasn't anything else we needed to do. So step 6, we're doing waveform analysis. So waveform analysis, we had to go over to the Cadillac because we were having issues with the Hyundai. Mr. Seitzinger told us to go over to the Cadillac. We connected the wand to our Pico scope. We hooked up our laptop, and at first we were having issues back on the Hyundai. We didn't have the waveform or chart set up correctly. And even when we did set up our chart and waveform on the Cadillac, we needed a little help from Mr. Seitzinger. But he set the trigger for us, and he kind of brought the waveform into proper focus so we could read it better. And basically what we saw at idle was a voltage spike of about 2.1 volts or 0.0021 kilovolts. And for dwell time, that's our 7th step, dwell time. We saw that we had a dwell time of around 4 milliseconds. So when we did turn up the RPMs, like we just essentially stepped on it, just revving up the car. We weren't seeing any differences with dwell time at all. We did see a difference in burn time, and you will see that in the video where I analyzed the waveform and kind of went over all the different components of it. So, okay, so right now, this is the waveform at idle. And here we have our 1 on our ignition coil. Now we're about to increase RPM. And you can see the changes that happen right there. So one thing I saw that changed was the burn time. Like the burn time got significantly shorter seemingly. So yeah, that's pretty much it.
So for our waveform analysis, we will be putting our pad on our coil and measuring it off of our pico.
Okay, so looking at this waveform, you have saturation about from here to here. Then you have dwell time from here until the voltage spike. Then you have the voltage spike. And then right here, you have burn time. It's around like this size right here. And then after that, everything after this is off.
Yep, as you also can see, our burn time is about 2 milliseconds from what it shows up like on the graph. And you can see our values here as well. We get a voltage spike of about, what would you say that's about? Voltage spike about,
It's almost 2 volts, or a little over, a little under. Okay, so now this is the discussion section portion. I'm starting off with question 1. I'll do 1 and 3. He'll do 2 and 4. So what is the relationship between coil resistance and secondary voltage? So the higher the coil resistance is, the higher the voltage in the secondary coil will be. And this is because the higher resistance you have, the more voltage wants to drop across that resistance. Higher resistance equals higher voltage drop, essentially. So I'll take it to Charlie.
All right, and for number 2, the question is, why is ignition dwell time critical to coil saturation? I wrote that ignition dwell time is critical because it can determine how current flow and how long it can flow through the primary coil, controlling how much time the coil has to build saturation and to help build its magnetic field.
Oh, okay. So question number 3, how does increasing RPM affect ignition coil control strategy? So increasing RPM causes shorter burn times, and you'll see this in the video. I analyzed it in the video, but this makes sense because if the piston is firing at a higher rate, the air-fuel mixture will have less time to burn until the next rotation of the crankshaft.
And for our final question, it says, what waveform clues can reveal weak ignition coils or poor wiring connections? And for me, I had put it could be between low primary ramp, uneven or irregular currents, low inductive kick, and short burn time. And then would you like to add yours on there as well?
Yeah, so I said that peak voltages can reveal weak ignition coils or poor wiring connections. I kind of just went to the slides and it told me this makes sense because the lower, like if you're not able to reach saturation, then your peak voltage is going to be much lower. And if you don't have proper connection, that'll cause the same thing. So now we're going to both do our conclusions. I'll let Charlie go first, and then I'll do my conclusion.
All right, so for my conclusion, I said that the ignition system tested operates as coil unplugged design. Each coil features an internal driver transistor as well as an igniter controlled by the ECM and fully controlled by the ECM. We determined through our investigation there are no visual or external faults. The system is fully electronically controlled. Adjustments are not applicable to the system due to it being fully controlled by the ECM. Coil unplug system seems to be working correctly and without any problems or strange occurrences.
Okay, and for my conclusion, I basically said that early on we were having issues with the Hyundai, and how to test it. We needed guidance, but we were eventually able to get past that, and it was smooth sailing pretty much from there. The things I learned in this lab, I learned about how RPM can shift ignition, like waveforms, like obviously the burn time. I didn't see too much else influenced by RPM, but I didn't know that before. And it was nice to learn all the different components and like parts of the waveforms, like what they mean, and basically what they represent. And overall, I thought that the lab was like a new experience. It helped me like learn some new things, and I got a little bit more kind of technical experience working on the car. So I enjoyed this lab.
And I will also say that I learned from this lab is how much a difference between a married and a separate coil ignition pairing can determine. It can determine a lot about the system, especially for on time, dwell time, and really just how our graph can show up on there. For the most part, I feel during this lab we learned a lot about ignition coils and learning about the things that create our graphs and how to learn from the graph and actually how to explain what is happening during our ignition coil operation. So overall, I feel like this lab was both a learning experience and also was a test of our knowledge to describe and contribute to our operation and diagnosis of our lab.
Thank you for watching.
Yep, thank you for watching.